we should start. Okay, I will be talking about creating containers with Perl, but it will be a completely different talk than the previous one because I will be more on the system side, how to actually create a container. But let's start. Who am I? I'm a system administrator by heart. I actually did a lot of teaching in Sofia University as for Linux system administration and network security. Also, obviously, I organize events like this one, and I'm helping a lot of the events in Bulgaria. And a few companies are paying my salaries, so CEO of 1H, CTO of GetCloudr, and I'm the chief architect of SiteGround.com. So these companies are actually the challenges for me. Actually, they drive my thoughts. They make me build stuff like the things that I will be talking about. So currently, containers are something new, something not very well understood. Unfortunately, it's not new. It's like 10 or 12 years old, or the first technology for containers actually started in '98. So it's not a new technology at all. And for people like me, system administrators, containers is something that we knew existed since the day one when we started learning Linux or BSD or any kind of Unix. So why it is so interesting now? Now it's interesting because we have LXC, we have Docker, we have let me contain that for you of Google. We have a bunch of other small implementations, and you could also build yourself an implementation to create a container. It's increasingly more easy to create a container. But what it is, a container, we will find out in a minute. The problem with containers is that, like Docker, most of the implementations are focused on one single application to be contained in a certain way. If you want to create a virtual environment with containers, I mean VPS, virtual machine, with containers, you need to have root inside this container. And having root inside this container means that this root may actually be root on your host machine. So this is a problem. There is one new technology in the Linux kernel called user namespaces. This allows you to map certain user ID to another user ID. So now you can create a user ID like, for example, 600 and map it to user ID 0. So inside the container, user ID 0 is root, but actually on the host machine, it's user ID 600. So you don't have problems with that it has root. Unfortunately, it's not so easy. If it was so easy, everyone would be running root containers in their infrastructure. It's not, because most of the kernel code is written in such a way that it checks if you have user ID 0. And you obviously have user ID 0 in your namespace. What?
Can't you just use fake root?
Fake root? No, not really. The second thing about root is that root comes with capabilities. And a lot of the code in the kernel is written to check capabilities. And even though you're changing the user ID, you're not changing the capabilities. And if you give every user the capability to reboot your system, he will be able to reboot your system. Was there a question there? Okay. So the only technology that allows you currently to run containers with root inside them is LXC. And this is because they're the only one that decided that this is a good idea and we should create an environment around this. So why would you need to write your implementation in Perl when we have LXC? Obviously, LXC is written in C first. Second, patching it, and you would need to patch it for certain things. As we started with LXC at GetCloudr, we had to patch it a lot to make it work for us. So in the past month or so, I was thinking, okay, why should we constantly change LXC when most of our infrastructure is written in Perl? And LXC doesn't bring you so much. You won't understand in a bit. Writing in C obviously has some problems with,
So excuse me, why LXC but not OpenVCL?
why LXC but not OpenVZ? Okay, I understand where you're coming from, but there is something. OpenVZ kernels suck. The problem with them is that isolation is not very good. So one container can actually overload the whole machine. Give me an OpenVZ container, and I will overload the host machine. I promise you. Can we do that? Okay. So let's continue. So the C part. When you're patching LXC, sometimes unforeseen shit may come upon you because someone forgot to check something. And buffer overflows in LXC are particularly dangerous because this is the code that will run a hostile operating system for you, meaning the virtual machine for the client. And if you have to combine Perl with C, you usually have to write some XS modules for Perl to actually directly bind to libraries in C. So you still write C code in your Perl to connect to the C library. This is tedious, and sometimes you simply don't do it and execute commands. Executing commands is a problem because when you want to execute like 400 commands in parallel, you require the memory, the disk I/O, and the CPU for that, and it's a lot of overhead for your system. So if you write everything in Perl, you have less moving blocks in your system, so it will be easier to manage it. Now let's understand what is it a container in Linux. I make this disclaimer because in other operating systems, containers are a little bit different. Some of the things are not there at all. First of all, I hope everyone here knows what chroot is, right? Okay, so unshare is this strange new thing. It is a system call that allows you to create a new namespace. And this namespace may be IPC namespace, user namespace, network namespace. There were 6, but I don't remember all of them at the moment. So the idea of namespaces is that your machine, your kernel, is running in a single namespace usually. But if you create a new IPC namespace, for example, you can have a shared memory with ID 100 on your host machine and shared memory with ID 100 in your next namespace inside the same kernel, and they would not clash. The software that runs in the second namespace will see ID 100 only in his own namespace. So this goes for networking, this goes for user namespaces, for time, for example. And these namespaces allow you to create separate worlds inside your machine, inside one single kernel. So this helps by isolating functionalities that usually require clash. With C groups, you add limitations for each of these namespaces, because if you simply separate all the users on your machine, this wouldn't be enough, because one user again can overload the host machine, and this is something that we don't want to have. Control groups are a mechanism that is evolving the past, I think, 8 years now, and it's still evolving. It works. It actually works. It has different mechanisms to limit CPU, memory, disk I/O, network. So you can actually use this to limit the containers in different in different sets of limits. C groups are hierarchical. This means that you have a tree of groups of processes. You simply add a group of processes. First of all, you can add only a single process, and all of its childs are now using the same limits. It's not like using U limits. If you know what U limit is, you probably know that it applies only for your current process. And when you fork, actually, you can change these limits, and this is a problem. And also, these limits are only per process, so the forked process have another set of the same limits. So it's a problem because, again, with too many forks, you overload the machine. C groups, when you push one process inside a C group, all of its childs share the same limit for this group. So this is very good for the limitation part. And after C groups, the last thing that you really need for containers is dropping capabilities. I assume that most of you here know what Linux capabilities are, but for the others, this is, for example, if you want to run ping on your machine, it requires a raw network socket. And usually, raw network sockets can be opened only by root. With capabilities, these parts of some parts of the kernel are made in such a way that you can give a process a single capability like capnet raw, which is raw capability for opening raw network sockets. So capabilities are around 39 at the moment, and you can give each of those to any process. They are per process, but they are also inherited. So when you limit the capabilities of the first process, init usually, all the other processes lack those capabilities and cannot gain them again if you have done so properly. So what we have in Perl that allows you to create containers. Obviously, we have Linux and Share. I don't remember the guy's name. It was unmaintained, so last month I actually took over the maintainership of Linux and Share. I added the latest functionalities for Linux and Share, and I also added setns. Setns is also a syscall in Linux that allows you to change your current namespace to another namespace using a file descriptor from that namespace. So this is enough to create a container and to actually enter inside a container. Now, what we do need for pure Linux implementation, it's Linux capabilities. I have wrote a module for this, but still the code is too crude, so it's not uploaded to CPAN, but maybe in a month I'll have it polished and it will be online at CPAN. The other thing is networking. Unfortunately, Perl works. I'm using Perl as a system administrator, so for me this is the tool of choice for fighting most of the stupid things in Linux. And unfortunately, some of the things that I can do in C, I cannot do in Perl. So I decided that instead of implementing access module to connect to already working libraries like libvirt, I decided directly to talk to the kernel from Perl. So I'm writing modules to access Linux networking directly in the kernel, so we can create new, set up new devices, set up new VLANs, and stuff like this directly from Perl. So now we wouldn't need to execute commands like IP or ifconfig and stuff like this to configure devices, because this means that I would need to fork, and understand me very well, I need to fork sometimes 400 or 800 processes in a single second, and it's not very good. So I decided that I would do this entirely in Perl. So Linux networking, I still haven't started that, but by the end of the year, I will have Linux networking module that will be able to manage network devices in Linux and VLANs in Linux. So after we have that, what I'm proposing is a toolkit. It's something like LXC, but written entirely in Perl. because it is easier to patch Perl. It's easier to change Perl in certain ways. And also, it's a lot easier to add additional, to add it to your other Perl projects. So what we need is Perl container start, Perl container stop, restart, list, stop, and attach is actually using setNS to get inside of the container. So for this toolkit, I'll explain what I mean because I already have this done. I'll polish it and have it on my GitHub account. So this is the start process. Usually when LXC is starting, it has similar process like this one. And I want to have it flexible for me, as much flexible as possible. So first of all, before we start reading the configuration for a container, we would have a hook that may prepare something for us. Then we read the configuration. I decided that I will use YAML files for configuration. And after parsing the configuration, I may need to translate it in certain ways. So I have a hook for that also. The hooks are currently empty for me, but I have prepared the infrastructure to have any code there, even executing bash scripts or whatever scripts. Then, after I have read the configuration, I already know what control groups I should create. So I'm creating the necessary control groups. And after that, after they're prepared, I have post hook. So again, before I have started anything else, before I fork, I can do changes with the control groups. Then we have the mounts. Usually, when you're creating containers that should have root, you should never use a shared file system. Sorry, Docker. It doesn't work this way in terms of security. Shared file systems and inherited file systems are inherently bad in security, meaning that a single hard link can actually leak your whole file system out to the container with a simple bug inside the kernel. So bugs inside the container are not so rare as everyone thinks they are. Actually, since we are managing our own container, we know that every version of the kernel introduces at least 5 or 10 new bugs while they are fixing 100 old. So you never know what will happen, so you have to prepare for this. So if you're building containers, I advise you to use LVM or something similar to LVM and give whole partitions, block devices to your containers. So prepare mount is actually hook that will allow you to prepare stuff for the chroot, mount everything that you need wherever you need it before you chroot. Then you simply chroot, but you're still root here. So after that, you can change, execute commands inside the chroot to prepare something for the actual startup of the container. Then you do the unshare. Usually when you have a full container, unshare will create all of the namespaces. It will have the flags for creating all of the namespaces. And for Linux unshare, I have created a simple flag that says all or clean all that allows you to create a container to unshare all of your namespaces instead of simply telling unshare which namespaces you want to unshare. So after unsharing, you're no longer in the same user namespace, network namespace, IPC namespace, and so on. So you may want to execute some scripts again to prepare something inside the container. Then you drop the capabilities, and this is really this is why this is still not on GitHub, because without dropping capabilities, these containers would be with full capabilities of your local root, so they are a security risk. After you drop the capabilities, and you have to do it properly, because there is a certain way you have a certain approach that you have to take, and after that, you still may want to change something. So Again, we have a hook for that. Then it's the networking. Networking, for now, it would be a shell script. But in future, it will be a Perl call directly to the kernel telling it that it has to configure ETH0 to whatever IP, whatever mask, add this v1, and so on. This way, we can simply talk to the kernel instead of forking 800 times. Then we fork. Why we fork again? This is the second fork because we want to execute the init here, and after executing the init, we want still to be able to execute a hook inside the container. This is why we fork. This is a little bit different than LXC, I think. And after that, this part here is in our child, but after we have started the container, we okay, not after, but while we are around here, the other process actually sets up the user mapping for your new container. The user mappings are the mapping of 600 to 0, 601 to 500 inside the container, and so on. So we do that. We have a final post hook, and it should be finished. So this is only the start procedure, and it's the most complex one of everything. Everything else is a lot easier. I have already prepared this, and it works on my laptop, but capabilities, yes. So the other thing that we need is Perl containers attach. And for this, we are using Linux ZNS module that I wrote, and this is the procedure that I have. Again, we read the configuration file. Why we read the configuration file here? Because we may want to set up additional limits to our before we change to the container. I haven't implemented the setting of new limits inside the control group, but it will be added soon. We have to check if the C group is there, and also if the C group is alive, because we shouldn't try to attach to a container that is not running. Attach is simply executing bash inside a rooted directory. So usually, and here I have missed something because I prepared the slides like 20 minutes ago, we first have to chroot here. Sorry. This is the one thing that we actually need from the configuration file, because it's written where your mounts are. The file descriptor here, you have to find a process from this container. So all the processes inside the container are listed in the tasks file of the control group. So you can pick any one of those processes and go to proc process ID, FD, the directory, and inside of it, no, not FD, NS is the directory, and inside of this directory there are file descriptors called net, minute, UTC, SHM, and so on for each namespace. Choose one of those and set it, add it to ZNS, give it to ZNS. And then if you're going to attach to a container, I prefer to have clean all. So all the namespaces you should switch all the namespaces to this container. The kernel knows how to do this. You don't need to worry about it. It will clean all namespaces. But also, you can have a different configuration for attach. So you can say, for example, you want to change only to the network namespace of this container and execute a few commands from your host machine. So the actual commands are on your host machine, but the network configuration will be done on the container. So for example, if you want to change the IP tables configuration of a container, you can simply say, okay, set NS, the network namespace of this container, and execute IP tables with this namespace. It's perfect, because this way we can change a lot of things inside of the container without SSH, without knowing the password, without needing to execute complex tools like VRSH to enter in a container. And this allows you to change the configuration without getting inside the actual container. So this is attached, and it's really useful tool. Actually, without it, I don't think a container implementation is full. And the other thing is stop. Stop should, again, check if the container is already started, if there is an init process inside of the container. And then we should simply use PC attach and execute halt inside the container. It's so easy. Sometimes halt doesn't work. We have seen that there is a problem with certain distributions. They simply don't want to shut down. So when they don't shut down properly, you can simply use Q -9 and kill all of the processes of this control group. Obviously, this should be implemented in PC stop. I haven't done so for the moment. It's crude work, but it would be finished soon. The other PC list, you want to list all of your containers. Current LXC implementation for listing containers requires a lot of CPU to actually work. So I decided that I'll have one simple assumption. If a container has a configuration file and also has a control group, it should be running if it has processes inside it and it has init. And I'll check only these things, and you can check those. You can get the list of processes from the cgroups file system, and you can check if there is an init process inside of some of those processes by checking the CMD line file in the proc for each process. So it's pretty fast. You're talking only to cgroup and proc when you're doing that. And you can list all of your containers pretty easy. And I would add more options to it soon. Currently, it checks everything and reports if a container is down or if a container is up. But I'll add only alive or only shut down, something like this, options to the PC list. The other thing, top. A thing that we really miss with LXC and other container technology is that all the processes are single processes on our host machine. And when you have 10,000 processes, running a PS and finding out your process on the host machine is really finding a needle in a haystack. So when you run top on your machine, you may see like 10 or 20 MySQLs on the top of the list. And which of those is your MySQL that you're searching for is unknown. Unfortunately, there is no easy way to see how many resources a whole container is using right now. The information is out there. You can get it from the cgroups file. Unfortunately, there is no tool to show you this information and manage it for you. I'm proposing to have a simple tool that looks like a little bit like the list tool, but it will collect the CPU, memory, I/O, and network usage of each container for the whole control group, and it will display it to you in a top-like manner. So you can pretty easily see each container, the resource usage of each container. And then it should allow the admin to sort the information by each resource, handle signals, because you may want to use this in batch, so you can actually get this information for another script. So also there should be a configuration interface, so you can actually configure how it will look like. This I haven't started at all. This is something that I really want the guys that are interested in containers to jump in here, because for this I don't have a clear vision. I don't know how it should work really. So I'll do something, but it would be nice to have your feedback for that. And that's it. one thing that I forgot to mention is restart. Restart should be implemented by simply doing stop and start, not implementing a new functionality only for restart. It doesn't sound very good to me to implement two things. So questions? Are there no questions?
Hi. What do you think about SE Linux? Could this solve your security problems, or do you think it's not yet there?
SE Linux can solve your security problems, but as you're well aware, security is the enemy of usability. So with SE Linux, you have two problems. First of all, you have performance issues, because enabling SE Linux in the kernel brings performance degradation in the kernel, because it does a lot of other things that the normal discretionary security model doesn't do. And the other thing is implementing your security module. If you want to have a full distribution inside of a container and control that with SE Linux, you would have only a few rules for, with SE Linux, and these rules will not guard you from everything. Unfortunately, when you want to be guarded well, you add more rules, and then the user will install one strange software, and it wouldn't be able to start because SE Linux would stop it on the host machine. Because all of the processes are working on one machine, on one kernel. So the difference is only the namespaces. And when you start it in this different namespace, SE Linux simply says, this is a process that shouldn't do that. And that's it. So it can help a lot, but performance-wise and usability, it's a problem. It's perfect for Docker images because they're a single application. And if it's not single application, there are like 3 applications there. You know what you have put there, and you're not supposed to add more things inside of it regularly. While on a normal Linux machine, I may want to install a Counter-Strike server, right? So this is something that you have to reconfigure SE Linux every time. There are other options there, like RSBAC. This is, again, mandatory access control, similar to SE Linux, but a little bit faster. And you can also use GR security kernels. I love GR security. It's not a panacea. It will not save you from all the problems out there, but it tries to help you by preventing the most stupid attacks in the kernel that can happen. And it also has some mandatory access control for the file systems, so if you want to implement that, you still have this functionality. Any other questions?
Recently, Docker spun out stopped using LXC and spun out their own implementation called libcontainer. Do you have a view on that?
I think that's a very good thing that they do because I found it stupid to use LXC when you can actually have it in your own implementation. When the only thing, as you saw, that actually wasn't done with Docker was unshare. So they simply need to add one and share code. It's pretty good to do it there instead of relying on outside software for a single syscall, right? It should be done this way, in my opinion. Other questions? Here.
Where's the code that goes along with all this?
If you want it, I can give it to you right now. I'm not proud of it at the moment. Oh. This is why it's not on GitHub, but GitHub/HackMan. I think we have internet here, so. Here are all my repositories, and I'll add Perl containers pretty soon. Okay? I may add the repository right now, so it's visible, but I would not push the code there because Again, I'm not very happy with the code there, and I don't want you to laugh at my code. But I can give it to you right now if you want. Okay. It's not a problem. Anything else? Okay, then thank you.